Hi, Assalamualaikum and good day to all participants. Welcome to Women in Power webinar 2021 entitled Asset Management for Power Systems with Novel Methods for Predictive Maintenance. I am Norfadila Abdul Aziz from IEEE PAS Malaysia chapter. Thank you for joining us today. This event is jointly organized by IEEE Young Professionals Malaysia and IEEE PAS Malaysia in collaboration with UPM International Students Association, UPMISA from UPM, Advanced Lightning Power and Energy Research, ALPER, also from UPM, and Micropollutant Research Center, MPRC from UTHM. So before we start our webinar today, let me give a very brief introduction on IEEE PAS. All right. Can you see my screen now? Okay. So IEEE PAS is actually for Power and Energy Society. So IEEE, or Institute of Electrical and Electronics Engineers, is an international professional association for electrical and electronics engineering, with its office is located in New York City. So it has reached globally, which have thousands of members and cover more than 160 countries. So PAS is under IEEE together with other 37 technical society, which PAS is the second largest technical society in the IEEE. More than 45% of the IEEE standards are created by PAS. So what is the benefit that you can get if you join IEEE PAS? So PAS has conducted many activities and events that can provide significant resources for training and learning activities, such as online webinars like what we are having now. And then we have training and workshops. We also have technical journals as well as the basic courses for industry novice. So from IEEE PAS Resource Center, members can have access up to thousands items in power and energy field especially. So everything is under one place where you can get tutorials, videos, technical reports, general activities, archive webinars, conference slides, and many more. So other than that, by joining IEEE PAS, you can increase your networking since PAS has global engagement throughout local chapters. We have 10 regions altogether, where Malaysia is under Region 10 together with other countries like Australia, China, Singapore, and Japan. And today, the speaker for our webinar today, which is Prof. Lina, is from Region 10. So here are the IEEE PAS Malaysia chairs, which started from 1994. Some of them are from industry and some of them are academicians. So currently, the PAS chair is Prof. Hazli Mukhlis from UPM. All right, so what we did under IEEE PAS Malaysia. So we have conducted talks, webinars like today, conferences, and also awards for outstanding engineer, where in order to receive this award, you must be an IEEE PAS member. And then we also have networking with industries. Like previously, we have speakers from industry like TMB, TMBR, and also when we are allowed to do face-to-face, we also have visits to this TMB and TMBR, right? We also conduct or give FYP project awards, and under IEEE PAS also, you can get grant or funding, such as for this year, we have funding or grant for education activities as well as humanitarian activities. Okay, so come and join us. So to be an IEEE PAS member, you need to join IEEE first. And special for student, there is a 1 year membership, free membership for 1 year. So if you have already renewed the IEEE membership this year, so you can take this advantage and be the member of IEEE PAS as well. Okay, so this is the Executive Committee of IEEE PAS Malaysia chapter for 2021. All right. So now, let's continue. Yes, so let's continue with the webinar today. We are actually very honored to have Professor Lina Bertling, Tjernberg. Sorry if I pronounce it wrong.
No problem.
Yeah, from KTH, the Royal Institute of Technology, for joining us today for the webinar. So thank you very much from Prof. Lina for accepting our invitation today. And now I'm going to pass over the session to the moderator of webinar today. We have Aznilinda Zainuddin. She is from University Technology Mara. Currently, she is the Executive Committee of IEEE Malaysia section and IEEE Young Professional Malaysia 2021. She is also the senior member of IEEE. So without further ado, I would like to welcome Prof. Lina and Azlinda. So now, Lynn, over to you.
Thank you very much. I'm Dr. Nur Fadila Abdul Aziz. So do let me know if you can hear my voice.
Yes.
Okay, thank you, Dr. Lina. Okay, Assalamualaikum and good morning, good afternoon, and good evening according to your time zone in this international webinar as people are joining us from different regions. First of all, I would like to thank all of the attendees for joining this webinar for the Women in Power Day, entitled Asset Management with Power System Applications with Models for Predictive Maintenance. I am Aznilinda Zainuddin from University Technology Mara, Malaysia, and also the Executive Committee for IEEE Malaysia Section and Young Professionals Malaysia will be the moderator for this webinar. Before we proceed with our webinar, I would like to remind our audience to follow IEEE Young Professionals Malaysia and IEEE PES Malaysia on Facebook, Instagram, Twitter, YouTube, Telegram, LinkedIn, and Clubhouse. This event is broadcasted live in IEEE Young Professionals Malaysia and IEEE PES Malaysia via Facebook page and YouTube channel. If you have any question regarding the topic, you can type your question in the respective chat box of the platform you are using, and we will read it out during the Q&A session. Okay, before we go on with our webinar, I would like to remind our audience to fill in the attendance and feedback form, which will be shared in the chat box. The certificate of participation will be given based on the marked attendance. Okay, excuse me for some of the background sound. So these are the challenges, okay, when we work from home. Okay, so before I hand over the stage, let's have a brief introduction of our esteemed speaker, Professor Lina Bertling Tjernberg. Dr. Lina is a professor in power grid technology at KTH and the Royal Institute of Technology, and also the director of the Energy Platform. She was previously a professor at Tjernberg University of Technology from 2009 to 2013, and with the National Grid from 2007 to 2009. Her research and teaching are focused on developments of the future sustainable electric power grid, with special interest in reliability analysis, predictive maintenance, and asset management. Dr. Lina is a senior member of IEEE and a distinguished lecturer of IEEE PES. She has served the governing board of IEEE PES from 2012 to 2016 and has been the chair of the Swedish PE and PEL chapter 2009 to 2019. And also, she has been the editor for the IEEE transactions on smart grid technologies. Dr. Lina is a candidate for the IEEE PS President-elect. Without further ado, now please welcome Professor Lina to deliver her talk. Professor Lina, the stage is yours for the next 30 minutes.
Thank you so much for this fantastic introduction and welcoming. I'm very happy to meet all of you. So I will share my presentation. Can you see my presentation now?
Yeah, it's clear, Dr. Lina.
Can you see my presentation?
Yes, yeah, it's clear.
Yeah.
Maybe you want to click the hide button at the bottom. There's a small window there showing the sharing. Maybe you want to hide that. Okay. That's good.
So first of all, thank you everyone for inviting me today. I'm very happy to meet you, and I'm showing here a very great memory from a fantastic moment. It's from the PS ISGT in Asia. We had a woman in power seminar, and it's from Bangalore, and you will see actually the leadership here in the middle at this time. Noel Schultz was our president, and I'm here between, and you will recognize some other familiar faces here. So I'm very happy to meet all of you today. And I will bring my greetings from Sweden. It's morning time now, and I'm very happy to start the new week by meeting you all. I included here three strong memories from activities within IEEE involvements. I was very happy to share a conference in 2006 in my core topic of probabilistic methods applied for power system. And in 2010, hosted the first ISGT Europe in Sweden. And here you see the group of amazing students supporting in the work. And this last figure here is from one of our chapter meetings. And I felt that I thank you for this very nice introduction to IEEE PS. And I strongly encourage all of you to get involved because it's an amazing organization, I think, that we are part of. And we can do a lot of things together, both locally in our chapters and meeting our international friends and colleagues. So again, thank you for the introduction. So this is me, and if you want to read more about my work or anything, you can find me easily on my email or my webpage. So the key messages for my technical talk today is that I will focus on one part of the contributions to the sustainable developments. And the overall concept is the asset management. And as I would like to underline today is that what we need in order to fulfill and achieve the sustainable developments for the society, we need to work with a circular economic perspective. And here adopting asset management systematic processes is a key solver. So that is one of the key messages I'd like to give with you today. My other key messages is related to standards. IEEE and other standard organizations, it's very, very important what we are doing in the collaboration to agree on the standards. And this is really needed for a successful joint development. One example, very recent examples where we have succeeded, I believe, is in the charging of the electrical vehicles. In Europe today, I would say that we have the new CCS standard for charging, and this is a very important and successful result from collaboration in standardization. The third key message that I would like to give with you today is about reliability analysis and the applications of preventive maintenance, and that this will give very important efficient tool for providing asset management. Specifically, what I will share with you are novel methods that we work with, which are using volumes of data and machine learning methods. in the way to predict the future of the equipment and to do support for preventive maintenance plans. And the figures you can see here are the UN Sustainability Development Goals. And here is a figure that is capturing how we are seeing the development of the power grid into a green power grid to solve, to support in this transition. And this is a book that I've written on asset management, where most of the figures are from. So in the introduction, I'd like to again reflect a little bit on sustainable development, because this is a key for all of us that we really need and want to contribute in this development. And for us active in the power system area, it could be of interest to see a little bit how is the technical system changing, how it is adapting, and what are the new developments that we can make use of to make this contribution. And the figure here is a very recent developed figure that we have done in my group in order to, in an application actually for a future research program. And how we here have divided the power grid is that we see it in three different key areas. One is the intelligent adaptable grid. And this is where we typically can use a lot of the new data to make predictive maintenance, to get a knowledge of our system, that the customers will have detailed information about their consumption and make prediction for future, and that we have a lot of new technologies in the system. The second area here, what we call it flexible hardware. And this is where we see that the transmission distribution system is further developed to make use of new power electronics. We see, for example, that we are mixing AC system and DC system. We see that we are connecting electrical vehicles, that we are connecting solar and local generation. So in this context, we need a flexible infrastructure for the distribution and transmission. The third topic is a topic where we have to look at the circular economic chain, that all material, all the equipment in the system here has to be developed with a circular economic perspective. This could, for example, mean that we will have in the EVs that we could have batteries that first are used here, and secondly, they might be used as a backup system to a wind farm or something. So we have to look at the long-term circular perspective of the whole technical system. One, as I see it, very inspiration development today is the organization or company SpaceX. And as you probably know, it's the same leadership as for the EVs of Elon Musk. When we look today and focus on the asset management, I think it's very inspiring to look at what they have achieved, because what SpaceX has achieved is to shoot up not only an EV car, because this EV car is actually now circulating around us, but what they have really achieved that is very key contribution is for the first time to use recycled material in space travels. And all the concept here, I think, is an inspiration for our asset management work. So the definition of asset management is to handle physical assets in an optimal way in order to fulfill an organization's goal while considering risk, where the goal could be maximum asset value, maximum benefit, or minimum life cycle cost. And here I believe in the development now that what we're doing now is develop the life cycle cost to be a circular economic perspective. And the risk could be typically defined by the probability of failure occurrences and the consequence. And for example, in our technical system, it could be unavailability of power supply to the customers. As I mentioned in the introduction, standardization is a very important tool in order to make a success in the development. And for asset management, the ISO 55000 is a family standard, and it's the first international set of international standards for asset management. For those of you that are familiar with maintenance and asset management, you might know about the PAS 55, and that is formerly, it's specification for asset management that was launched by the British Standard Institute in 2004. And a major difference between the ISO 55000 and the PAS 55 is that the ISO 55000 is focusing on any type of asset type. And it's also aligned with other major management systems. So for a lot of organizations already are following other standards like the quality management standard or the environmental standard or the risk management standard. So it will be an easy adoption to further development of the use of standards. It also uses what's called Annex SL, and what's mean with that is a high-level structure, which will make it simpler in the implementation of the standard within the organization. So here are a few words in the terminology that I want to just underline, that in this it's ISO 55000, you will see, for example, life cycle, that is the stages involved in the management of an asset. And also I have noted here the predictive action. That's an action to monitor the condition of an asset and predict the need of preventive action or corrective action. So those are the focus for my talk today. But also I think here to focus on the end of life is another important perspective. This figure here, I think, gives an overall maybe summary and perspective of the main comment I would like to communicate to with you. And it is the value of using maintenance as a strategic tool. If you see in the figure here, there are three different policies that I'm visualizing. One policy is the maybe most simple, direct one that we are using a lot of the time without maybe even thinking about it. And that is that we are doing basically nothing. We're waiting until a failure occurs, and then we're doing what we call corrective activities. However, the whole contribution here, the smartness in it, is that we know that if we do some good activities, it's actually possible to increment the value of the asset. So we can gain a value here if we do an activity, a maintenance activity, that can increase the value. However, everything we do will also cost us resources and time. So we need to be smart and select the most appropriate maintenance plan. So that is the key solution of what we're trying to gain. Before continuing, I would like to make a short reflection about the concepts here in order to have a very clear picture. So when we discuss about maintenance, maintenance can be two different categories. Either the corrective that I mentioned, and this would be traditional one that we are just leaving the technical system to operate, and when something fails, we are correcting it. But the other alternative here would be to do a preventive maintenance. And when we do a preventive maintenance, we can be smart because we can do something very positive that is contributing. And there are two different typical ways to do this. Either a predetermined maintenance. Very classical example of this could be oiling that you do maybe every year, or you go out and you have a visual inspection and you do some kind of maintenance on the system. But the other alternative is that you're actually doing condition-based maintenance. And this is where we can contribute with our models and to based on some kind of condition, either continuous measured or collected on a schedule or on a request. So based on this information, we can make some kind of smart recommendation for a decision on the maintenance. So this would be the focus that I will discuss with you today. Before continuing, my first example here is something that's ongoing, and I thought it would be very interesting for you to see because we are targeting a deadline in December this year. As you are aware, today we are all part of the Society of IEEE, or hopefully you will if you're not today. But there are also other societies that we collaborate with. And CIRED is one organization that's collecting typically technicians and scientists working in the distribution level. And CIRED has a conference every second year. It will be a conference this year. And within CIRED, there are technical committees. And a lot of people are technical committees in CIRED, will also be in technical committees in IEEE. And I'm currently now leading one of those technical committees together with a colleague. And the topic for that committee is on lifetime extension options for electrical equipment. So I would like to include that just to give you a flavor of what is happening here. So this is really an area where both from our academic side, but from industry, that we're very excited about for future. And here is just a motivation for the work, that we see that the electrical equipment, they consider a large part of the asset values for the distribution system operators. The lifetime could be over 40 years. And some components age faster. And what we see now is that we have a quite fast evolution of technology. So in some contexts, we maybe need to replace things faster than before. And we also have a very strong developments for environmental and safety requirements. And this can also lead to that we should replace technology before the end of the lifetime. And that we are working now on the energy transition for the sustainable development. So we see that related also to the standards of the asset management, the target is to do a lifetime extension or upgrading of critical equipment, and also that we can use monitoring as an important tool for this. So extending the lifetime equipment, it could be a strong contributor to circular economy. And here we can use a lot of the input data to make predictive input. Here is also a recent publication we have in this topic. And I was happy that one of my PhD students, you were presenting her thesis in the beginning of the year. So now I will go to my last part of my presentation, where I will say a few words about applications we have done for wind power. I include this figure here in the beginning, so just to give you perspective on what we are looking at here. And this is the application we do is for offshore wind farm, Lillgrund. It has 48 turbines. It's 110 megawatt, and it will cover around 60,000 households. This one was put in operation 2006, and at that time, it was actually the world's largest offshore farm. But today, these turbines start to look small if you compare to what we are putting in operation today. I want to give you here a perspective of the challenges we have in the maintenance. Obviously, this is a similar, same turbine, but this is located onshore in Smøla in Norway. And this is taking up, you see here, this is the turbine, actually this one. And we were actually walking inside this one, following some very interesting aging phenomenon that we were modeling afterwards. So this is myself and my former PhD student, Francois Bernat. So the motivation we have here is that wind power is, of course, a key solver for the sustainable development. However, we need to reduce the high operation and maintenance costs that are major challenges for the wind power development, and especially for the offshore. And here again, you see a figure and get a feeling a little bit how hard it is to perform the maintenance outside here. This is the overall description of the framework that we have worked with. And the idea here is that we take in data from SCADA, data supervisory control and data acquisition system. And then together with alarms and warning and also recorded measurement, we give input here, and then we have created an artificial neural network model. And we are training that with this data. And then we are also taking in vibration for the equipment. And then we're planning our preventive maintenance to give an input for the maintenance planning, and at the end to make decisions, smart decisions for the maintenance. And the framework, it considers a short window of time which exists between an indication of an impending failure from the condition monitoring system and the eventual failure of the component. So it's a short time frame that we're working on this model. And here I'm mentioning the different input data. We have SCADA as a primitive input, and there are the two parts of the data, the operation data and the alarm logs data. And the operation data are usually average every 10 minutes data. And we are using that to forecast the behavior of the wind turbine. And then we have the log records and the reported operation errors. And that detect the time and the corresponding system information. And this is used to make the decisions. And then it's we will not be able to go in details here, but obviously when we're working with these type of models, it's a lot of work in the processing of the data and classification, etc. of it. And I'm happy to share with you the publications if you want to go in more detail. And here is a little bit more description about the model that we have developed here, and also how we're trying to reduce the errors in the model. At the end, I want to show that we have validated the model from a case study. And for the case study, we are using data for 2 different wind turbines, and it's the same manufacturer, and they are 2 megawatt, these turbines that you saw. And for the validation data, we have used onshore wind farms located in the south part of Sweden. We have also focused on the equipment of the gearbox, and in the early wind power development, we could see that gearbox was the equipment with the greatest challenge and failure consequences. And the typically here is a planetary gearbox with a 2-stage parallel shaft gearbox. I will show you a figure shortly, and this is typically used in the wind power. We are collecting several parameters, counting, for example, the bearing temperature, the lubrication oil, and the lubrication oil pressure are monitored and recorded in the SCADA system. And here you see a graph explaining the gearbox, and you see in red the different locations where we have the measured data. And it's 5 bearings, and we have, for example, the information of generated power, the temperature, and the rotor rotations. So in the application here, we are applying it, as I mentioned, for the 2 megawatt data. And in order to validate the model, we were very happy to get data where we have an actual fault happening and then a replacement. So this is a way for us to validate and see if it was really possible to predict the fault before it happened. So in the model, we are using 2 neural networks, and we are creating this with the output of the bearing temperature and the lubrication oil temperature. And we are using 4 attributes that are the nacelle temperature, the rotor speed, the ambient temperature, and the grid production power. And then we are using operation data for 1 year to train the model. And then we are using the 14 months for testing the model. And here we are using temperature signals to explore the possibility of possible anomalies. So what we are doing here is trying to predict this failure before it happens. And here a little bit figure trying to visualize the work in the input data, and also here. And I will make a summary comment here. So we are basically managing to, we are creating the model, and we are also collecting a number of inputs. We have warnings, alarms, and it is an alarm in 2012, and then we have indications. And then we can also see that even though there were these warnings, the alarms was not triggered. And it's showing here the complexity in how we can get an alarm in the system. So in summary, what we have done here is to present a machine learning model where we're using SCADA data for the condition monitoring of wind turbines. And the main contribution is that we can consider the SCADA alarms with the condition monitoring and machine learning technique. We could show also that by using the both alarm logs, we could indicate the possible anomalies in the wind turbines. It's also shown that we could do this in an early stage to detect the possible failure. So this was what I had prepared today. So I'm very happy to take any questions. And now I will try to come back here so I can stop sharing. So, hello. So, I'm happy to take any questions now, and was happy to speak with you.
Okay, yeah, thank you very much, Professor Lina, for the enlightening talk. Okay, yeah, now we open for the session for Q&A. Anyone have any questions? You can drop your question in the chat box.
I think there are some questions, yeah, in the chat.
Okay, let me read one of the questions. Okay, yeah. Okay, how many data was needed to train the ANN system for the wind turbine predictive maintenance?
Well, in this examples, in the validation example, we had 1 year of training data. And as I also mentioned, we had around 10 minutes data. So that's what we were using. And the reason, so that's what we were using for the case.
Okay, anyone else have any questions? Okay, let's take another question. Okay, Professor Lina, what do you think of deep learning algorithm for predictive maintenance?
Well, I think it is. It will be. It's a useful methods that we can work with. I think also I would like to mention that for me, I'm trained in a classical applied mathematics, where actually when I was trained originally, we didn't have these kind of methods. So originally, I was trained in analytical methods where we used failure statistics. So what I say is that I'm excited about the machine learning methods, but I also strongly believe that it's also important that we, if we can, that we also have experience data and more specific knowledge about the technical system. And that's also why I showed here on the validation that I think is very interesting, that we actually have real data. But I'm very happy in working on the development of the new methods also for machine learning. Thank you.
Okay, let's take one question here from the participants. Okay, we have one problem from Professor Zuhaina. Professor Lina, in your opinion, is asset management a good area for research?
Thank you so much for this question. So asset management, as I defined in the beginning, is actually a very wide concept. And I think when we look at the targets we have now for sustainability, we know that circular economic is a key factor. And since I worked in asset management for so long time, for me, it's obvious that asset management, a key solution of that is circular economic. So I definitely think it's a very good area for research. What's important, however, is that we scope down. So what I have done here, for example, is that I try to look specifically on reliability aspect and how we can impact on the system level. And I think asset management could include a lot of different scientific areas. It could be people working on economic aspect or maybe social aspect. So I think it's a wonderful area for research, but it's also important as a scientist to get your kind of depth in it. So it's an exciting research area in that context, that you can both need your depth and also your more system level. Thank you.
Okay, next question from Salman Yusuf. Have you tried algorithm other than ENN?
Well, we are working on that, and I think my PhD students will be much better than me on answering that. But we are, yes, we are looking. Actually, what we are doing currently is that we, because the application you saw here is that we have focused on wind turbine aspect, and wind turbine is quite a. I mean, it's an equipment that's standing on a place. It's kind of located, but now we have moved to, we're looking at transmission system, and that is a bit challenging because the equipment, but now we have moved to, we're looking at filtration system, and that is a bit challenging.
Sorry.
I was hearing myself. And in that context, we're focusing more on the equipment level. But we are using neural network in that context. But we will try other algorithms in future. So I will be happy to return back on that question. Thank you.
Interesting. Okay, next from Johaida Yusuf. Prof. Lina, can you explain more on the sizing of the wind turbine, which is what do we consider?
Thank you for your question. The size, I mean, if we generally discuss about the size of wind turbine, the one that I showed here is a 2 megawatt turbine. And today, that would be probably considered as a quite small size. I know that if you look at the offshore investment today, I think they're up to 10, maybe 12 megawatts. And the reason, obviously, is that it's a very the benefit is much greater if you go up in size. So it's very clear on wind turbine generation that the larger size, give you a better benefit back. So that's what we can see very clearly. But if you are building onshore, typically you will have constraints of the height because you don't want to interrupt too much in the nature and the context. So that's why we still have smaller, typically onshore. But if you go offshore, you would typically go up a lot in size and also get a better outcome, probably, from the benefit.
Okay, can we bring another question? Okay, so this one from Tazkira Harriet. I'm Hakim as a civil and structural engineer now. I have one question. What is the biggest challenges during doing the wind power research?
Thank you so much for your question about what is the biggest challenge in doing wind power research. I think generally, as being a scientist, a challenge is to get the data. But since I work on transmission distribution also, I can say that in wind power, we had the privilege of getting access to data. In transmission system, it's almost impossible to get data because it's a lot of security in it. But in general, get access to data is very difficult. But in wind power research, I would say that one difficulty is that they are very advanced themselves. I would say that the wind power industry is very efficient and is really excellent. So it sometimes it could be a bit difficult for us as a scientist to know what they have done and not. So that is, I think, a challenge. We had the privilege of collaborating with a small company that is helping. They are actually helping wind power operators to forecast and plan the operation. And that company, they are experts in working on machine learning models, etc. And one of my former PhD students is working there. So I think that was for us a way to get access to the data. But normally the access of data, I would say, it's always a challenge in our scientific work. Thank you for the question.
Thank you, Hakim, for the question. Next, we have from KJ Peh. What will be the safety management challenges in terms of safety?
Yeah, so thank you for the question. So the question was, what are the safety management challenges? If we specifically look at offshore wind, it is quite challenging in the transportation out to the farms. And one of the models that we work with have been an optimization of the transportations to and for. And depending on what type of replacement or reparation you're doing and what time of year, etc., you would use different transportation. And you can also use helicopter if it's needed. You saw that when you're opening up the turbine, you need to pick down the large items. So obviously being on the sea out is challenges because it's a lot of movement, so all that around is very difficult. But in general, when we work with a high voltage, it's always a matter of having good safety and protection system. So you have a good protection system in your electrical circuits. I mean, that is, of course, always the key factor in every kind of aspect. Thank you.
Okay, next from Salman Yusuf. Do you have actual data on the cost saving as a result of predictive maintenance?
Thank you so much for this question about the cost savings. I didn't include that example in my presentation today, but I have another example where we are when we performed a complete life cycle cost estimation, and we could actually reduce the cost. I think it was maybe 10-15%, something like that. That we could show that was possible to do when we were optimizing the maintenance efforts. So we have some past experience of that, yes.
Okay, thank you, Salman, for the question. Okay, we have a lot of questions, okay? It seems like, okay, now we have one from Kanchit Ng. Have you ever tried to use this approach in other complicated area or system for predictive maintenance?
Yes, thank you so much for this question. And I think I was answering partly before, because my former PhD student, Yu, that presented, was the main author of this paper. We currently now had a new project where we are focusing on high voltage equipment in the transmission system. And we are now focusing on the transformer. And transformer is a very complicated equipment. As we all know, it's one of the fundamental equipment in our power system. So definitely we are working on it and taking small steps forward, because we need first to really get an understanding on the condition monitoring aspect of a transformer. And if you compare science in transformer and wind turbine, it's very different. Oh, hello. Because we have a transformer area is a very well established area. I mean, the first transformers came in the century. So in that sense, there are already standards for condition monitoring. So what we are actually working on that is some exciting work where we have access to data. And this is ongoing work, so I will be happy to come back to you about that. But we're definitely working on that for other equipment. Thank you.
Okay, thank you, Kanchit. Okay, we have another one from Hafizullah. How much region we can control through SCADA?
I'm not sure if I understand the word region. What do you mean? How much?
I think maybe region. I think maybe he's referring to region.
Yeah. I think, I mean, if I look at the example that we were looking at here, we use the SCADA to indicate, I mean, to give alarms. So I would say that the limitation we had was not really on which equipment we can look at, but rather the time aspect, that we only had it for 10 minutes. So I think that is important, that if we want to do a lot of the predictive maintenance, we need other more frequently time information. But otherwise, I think we could look at, I mean, in this case, I showed we had 5 different sensors, and I think we can have a lot. It's the sensors now are not so expensive. So I would say that we can take in a lot of information from the system, the actual system that we studied. Thank you.
Okay, let's another question from Abdullah Ashur. May you tell me about prevention maintenance in solar energy equipment?
Oh, that's very interesting. For solar energy, we are starting to look at that as well. But the good thing is that it's not really so much maintenance as we have seen. I mean, you need to clean, you need to keep it clean. But we haven't started yet. We haven't really got any exciting data to work on for the predictive maintenance. But obviously, we are working on the reliability aspect of the solar and sizing aspect. But I think a strength with solar is that it is not so much maintenance. And a lot of the equipment related to it doesn't have so much aging, I think, perspective, or it's more that you would replace when it fails, some equipment of it. So I would say that the preventive maintenance would be much related to maybe inspection and cleaning to keep it, the good system going. Mm.
Okay, next from Amir. How much would you rate the percentage of success in using the machine learning method for predictive maintenance?
Oh, that is a very difficult question. I think I try to think always that as an engineer and as a scientist, I always want to give an answer. And depending on what kind of data I have, I will use different tools. So I will use machine learning tools if that is what's more applicable, or I would use other methods. So I would say it's really different depending on the situation and also the volume of data you have. So I couldn't really give a percentage. Mm-hmm.
Okay. Okay, next we have from Muhammad Mahadi. What about the upcoming research trends for smart grid for area of cybersecurity and or any kind of advice for doing research in the following areas?
Well, thank you so much for this question. It's a bit wider than my speech today, but I'm very happy to answer. I actually have later today, one of my students present her master thesis, and that's related to this topic. So if you send me an email, I will invite you. So we have actually studied the question of cybersecurity related to risk assessment, etc. And this is obviously a very, very important question. And it's also important for the condition monitoring, because the data, every data we collect today, we have to be aware that someone else can actually use it or try to actually change it. So we have to be very careful with data to protect the data and make sure that it's not accessible. So this is a very important topic, definitely.
Okay, thank you, Mahadi, for the question. Okay, we have next from Faiz Omar. How do you determine the input parameter to be used, for example, in the case study for wind power O&M?
Well, I would say that the input parameters we are selecting would depend very much on the specific case. For example, if we have a wind turbine here, we know that that the temperature would be really important, vibrations. So I guess it's an experience depending on what kind of system we have and where it's located. That we would know. And that's why I say in the beginning that I think the technical experience and knowledge is also important. But of course, it's also related to what kind of data we can get. So it's always a balance of that together.
Okay. Thank you, Faiz. Okay, next from Taufik. Other than the need of past data collection, what would be an existing weakness of predictive maintenance?
Well, it could be that it gets too complicated, that it takes a lot of resources to work on it. Because in past, my starting subject in the research was on reliability-centered maintenance, and that was developed originally from the aircraft industry, where they really needed to reduce the amount of maintenance when they got a larger development of the Boeing airplane. So in predictive maintenance, I would say that it's important that you select your most critical object and you make smart decisions on the data. Because if you do too much, it will take too many resources of you. And that is why I like to relate it with some kind of reliability assessment where we start to focus down and select the critical equipment. If in the case study, we selected the gearbox, for example, that we know was a critical component for the system reliability. So I think the focus is important and not to collect too much data. Mm-hmm.
Okay, we have another one from Nur Najiha. Do asset management, do water preservation or treatment? If so, what is the asset management current project and water treatment?
Well, I can say like this, that asset management is a systematic framework and approach. So it is applicable to all kinds of applications. So yes, it could include water treatment. I don't personally work in that perspective, but it's of course a very, very important perspective. And I could connect you with other people that would work in that kind of area. Mm-hmm.
Okay, thanks, Najiha, for the question. We have another one from Mohammed. How can we store the wind power faster in a battery? Is your method suitable for faster discharging?
Well, I can say like this, that I think the combination of wind farms and battery is a very good development that we see. And we have a couple of examples for that. The method we have worked with here, it's not related at all actually to the generation in that context. So I'm not sure, but it's a good combination to do battery storage and wind. But I'm not, and when you do. Yeah, but I'm not commenting on the technology for the charging because we're not working on that. Thank you.
Okay, thank you, Dr. Lina. I think that's the last question that we will take from the participants. We do have a lot more. Thank you, everyone, for the question. However, we won't be able to read all of them. Okay. Okay, so I think that's all we have for the Q&A session. Okay, so with that, we would like to thank you again. Thank you very much, Professor Lina and audience. And we are looking forward to meeting you all again in our future events. And probably we will share with you maybe your email, Dr. Lina, if possible, if anyone wants to contact and further question. You guys have any further questions? Okay, we will share the Dr. Lina's email in the chat box. Okay, so please follow the, do not forget, okay, to log in your attendance, and please follow the IEEE Young Professionals Malaysia and IEEE PES Malaysia Facebook, Instagram, and YouTube channels to stay updated regarding the events and activities that we have in the future. I would like to remind all audience to fill up the attendance and feedback form, and the link is shared in the chat box. And with that, and again, thanks a lot to our esteemed speaker, Professor Lina, and I, as Nilinda Zainuddin, signing off with all the best wishes and spirit to stay motivated during these difficult times of pandemic. Learning and sharing must continue no matter whatever the situation is. I apologize for any flaws and thank you for sparing your valuable time, and see you again in future event, inshallah. Take care. Fi amanillah.
Thank you so much.
Hi, do you know why we should engage with IEEE Young Professionals early in our career? Well, what is IEEE Young Professionals and how can it help us? IEEE Young Professionals is an international community of enthusiastic, dynamic, and innovative members and volunteers. Any IEEE member can be a young professional, and any member who received their first professional degree within the last 15 years is automatically considered a YP. Now, IEEE Young Professionals is bigger than you may think. It is one community in 10 regions across 183 affinity groups and more than 120,000 members around the world. So, why should we engage with IEEE Young Professionals, you ask? It is a place to connect and network with other professionals, enrich our career and personal lives, and participate in social events and activities. We can participate in many professional networks such as IEEE Collaboratech, IEEE email account via Google Apps, and take part in local meetings and online activities such as conferences and job fairs. We can also access the IEEE Center for Leadership Excellence for on-demand content. This really is an excellent resource to equip us with professional development skills. The benefits go on and on, particularly for young professionals early in our career as well as students. We can enhance our technical skills by accessing ebook classics, IEEE member digital library, Spectrum and Potential magazine, IEEE Explore, conferences, and more. Look, the bottom line is this. We can participate in exciting local events and global webinars for topics such as assessing emotional intelligence, fundamentals for leadership and ethics, heroes networking for engineers, survival guide for scientific writing, conflict management, negotiation tactic, and others. For all these great reasons, engaging with IEEE young professionals may be one of the best decisions that we can make in our personal lives and professional career development. That is why we should engage with IEEE young professionals.